Hi everybody. In this video, we're going to solve some time value money problems, which we did in the recitation session. Mainly this is to give the people with the TI-83 calculator a chance to see how to use a calculator to solve problems. But also I'm going to do some problems in Excel, and I'll go into some more fine details within some of these problems. So I think this is valuable to watch to the end, even if you're using Excel. So let's go and get started. So we'll start with a basic question. So Sam deposits $1,000 today into an investment account that pays interest of 10% per year. We want to know how much he's going to have in the account at the end of 2 years. All right, so this is going to be a future value problem because we want to find out what we're going to have in the future. So let's set up a little chart to figure out what our inputs are going to be into the calculator. So we'll have an N, we'll have an I, we'll have a PV, an FV, and a PMT. Those are going to be our standard inputs that we're going to put in every single problem. All right, so we're going to have an N. How long are we investing? So the N is going to be the number of periods we invest. So this is going to be 2 years. We have I. I is going to be the interest rate that we're going to have. So we'll have 10% per year. Our PV is what we're starting with, what we're going to have in the present. So we're going to make this negative 1,000. Why negative? Because the calculator needs things in terms of inflows and outflows. So if it's a cash inflow, we'll make it a positive number. If it's a cash outflow, money coming out of our pockets, we'll make it a negative number. So since Sam is depositing this money, cash is coming out of his pocket, we're going to make it negative 1,000. We're solving for future value. We want to know what we're going to have in the account in the future. And for now, we'll let payment equal 0. Now let's go to the TI-83 calculator and see how to input all these things. All right, have my calculator out. Now let's see how to actually find future value using it. So I'm going to go into apps here. So this blue button says app. That's going to get me into my applications. I have a finance application, so I'll press enter to enter that. And then I'm going to use this TVM solver. That's time value money solver. So I'll enter into that. And now you'll notice that we have something that looks similar to what we have here on this chart. So I'll just start inputting the values that I already found. So N is equal to 2 years. I is 10% per year. My present value is negative 1,000. Since we're depositing $1,000, we're going to have it as negative. We're going to leave PMT as 0, and we're trying to solve for future value. So in this calculator, you're going to hover over what you want to solve for, and then press alpha, this green button here. So I press alpha, and then I'll press enter. And that's going to solve for the value that I'm hovered over. So I get 1210 as my future value. So I'll go ahead and write that down over here. We have our future value is equal to 1210. Now I want to see what happens if some things change. What if N increases? So instead of investing for 2 years, we invest for something like 15 years. What should happen to the value that we have in the account at the end of 15 years? Well, you should have an intuitive feel about what's going to happen. What does it mean if we increase N? That means that we're investing for a longer time period, so that means we have more time to earn interest. So as a result, future value should increase. But let's test it out to make sure that's the case. All right, I got my calculator back up. And yeah, let's see what happens if we change N from 2 and increase it to something like 15. All right, so I'll go back down to future value, press alpha enter to solve for it, and we should see it get bigger. We get 4,177. And that's just because we're getting interest over a longer period of time. So that's going to make the account balance larger. Let me change it back. And now I want to see what happens if we increase the interest rate. Let's say the interest rate goes from 10% that we have now, and we'll raise it up to 20%. What's going to happen to the future value? Again, it should be intuitive in terms of what should happen. So what does it mean if we increase the interest rate? It means that we're going to get more interest. So what's going to be the impact on our future value? Well, it should make our future value higher. So let me increase my interest rate from 10% to 20% and solve for future value again. So I'll go to alpha, enter, and you'll notice that I get 1440, which is bigger than the 1210 that I had in the original problem. So yeah, as interest rate increases, future values can increase as well. So those are two relationships you should keep in your mind. As N increases, future value increases. And as I increases, future value increases. Let's do another problem. Let's say that we want to have $1 million in our savings account by the time we retire, 40 years from now, and you find an account that's going to pay you 3% per year. How much do you need to have how much do you have to deposit to reach your $1 million goal? All right, so this is going to be solving for a present value. We want to know how much we have to put into an account today to have something in the future. So we're going to solve for present value. So I'll set up my chart to see what my inputs need to be. So I'm going to have an N, I, PV, FV, and PMT. All right, let's start filling this out. So what is the N going to be? N is going to be how long we're investing. So we're going to invest for a total of 40 years. My I is going to be my interest rate. So this is going to be 3% per year. PV is what we're solving for this time. We want to know how much we need to put in the account today in order to get the future value of $1 million in the future. And I'll make PMT equal to 0. This time we're going to use Excel to find this, solve this problem. All right, I have Excel up and I'll have my input table over here and I'll just start solving this problem. So we're going to solve for present value. So I'll put in equals to get into my functions menu, and then I'll type in PV. And I'll open parentheses, and then I'll get a list of the things that Excel wants to know to be able to solve this problem. So it wants to know what is the rate, what is the interest rate. So this is going to be 0.03. And then it asks you what is the number of periods we're investing. Well, we're investing for 40 years. What is the PMT? For now, we're going to have that as 0. What is the future value? This is going to be $1 million, positive. And then it asks for type. For now, we'll just leave it as a default, which is going to be 0. Close the parentheses, press enter, and that's going to give us the value. So we get $306,000 as our present value, negative $306,000. Why is it negative? It's negative because we have to invest that. We have to have a cash outflow. So if you deposit $306,000 into the account, in 40 years, you can withdraw $1 million. So that's why we have the negative sign right there. Let's solve for N now. N is going to be the number of periods. So let's say Sally deposits $100,000 into an account today, and the account pays 4% interest per year. How long is it going to take for the account balance to grow to $500,000? All right, so just as always, I'll make a little chart of my inputs. So we're going to have an N, I, PV, FV, and PMT. All right, my N is going to be what I'm solving for. My I is going to be my interest rate per year, so 4% per year. PV is what we're going to deposit today in the present, so we're going to make that $100,000. And I'll make it negative because Sally has to deposit this, so it's going to be a cash outflow. My future value, we want it to grow to $500,000 in the future, so that's going to be my FV, and we'll leave PMT as 0. All right, so now again, let's go into Excel to solve this problem. All right, so in Excel, I have my input table set up. I'm going to press equals to get into my function menu, and I'll type NPER, so the number of periods. Open parentheses, and it asks me what is the interest rate. So this is going to be 4%. Then it's going to ask me what is the PMT. We're going to leave that as 0 for now. What is the PV? The PV is negative $100,000. So we're depositing $100,000. And then my FV is what I'm getting, what I'm going to have at the end. So $500,000 at the end. And then type, we'll leave it as the default, which is 0. Close parentheses, and I get 41. 41 what? It's going to be 41 years. So Sally's going to have to wait 41 years for her investment to grow from $100,000 to $500,000. Now let's see what happens if we change some things. What if our interest rate increases? What's going to be the effect on the time we have to wait for our balance to grow from $100,000 to $500,000? Well, as before, you should have an intuitive feel for what's going to happen. What does it mean if we increase the interest rate? It means that we earn more interest over the period of time we're investing. So if the interest rate increases, then it should take us less time to reach the goal of having $500,000. Well, let's just put some numbers in to prove this to ourselves. So we're going to change this number here. We're going to change this 0.04, which is the interest rate. And let's make it, let's say 10% per year. So instead of 0.04, I'll make it 0.1. And then I'll solve now. And you can see the number went down. It went from 41 years to reach our goal of getting $500,000. Now it's down to 16 years. So as the interest rate increases, it's going to take us less time to reach our goal of having $500,000. Next, we're going to find an interest rate. We're going to solve for I. And so that's really useful when we're trying to find an implied rate of return on investment. So let's do that here. So what's the implied rate of return on an investment that promises to pay you $10,000 in 15 years if you invest $7,000 today? So as always, I'll write my chart. So I have N, I, PV, FV, and PMT. All right, my N is going to be 15 years. That's how long we're going to invest. I is what we're solving for, so I'll leave that blank. PV is going to be what we invest today in the present. So I'll make that $7,000 and I'll make it negative because we're depositing or we're investing $7,000. That money's coming out of our pocket. And then in return, we are going to receive $10,000 in 15 years. So we'll make that a positive number. And then we'll make PMT equal to 0. Now let's pull out our calculator, our TI-83 calculator, and try to figure out what the implied rate of return is on this investment. All right, I got my calculator. I'll go into apps, I'll go into finance, and I'll go into the TVM solver. So my N is 15, so we're investing for 15 years. I'm going to solve for I, so I'll skip that for now. I'm going to have a present value of negative $7,000. PMT will leave that as 0, and FV will make that 10,000. And I'll go back up to I, and I'll go to alpha, enter to solve for the interest rate. All right, and so I get 2.41% is my implied interest rate. And that's the answer to this problem. So what's the implied interest rate if they're going to give us $10,000 in 15 years if we invest $7,000 today? That implied rate is 2.41%. We'll do the same problem in Excel. So we'll do it real quickly. So I'll have equals, and the function I need to use to find the interest rate is rate. So I'll do rate, open parentheses. It asks for the number of periods we're investing. So this is going to be 15 years. My payment, I'll leave that as 0 for now. Our PV is going to be negative $7,000. That's what we have to invest today in order to get $10,000 in the future. So it's going to be positive. Our type is going to be 0. We'll leave that as the default. And then it asks you to give a guess, but that's not going to be necessary for us. So I can simply close the parentheses here and press enter. And so I get the result of 2.41%, which is the same thing I got with the calculator. Next, I want to talk about how to deal with multiple compounding periods per year. All right, so what we have to do is we have to make a couple of adjustments. We have to adjust the N in our problem, and we have to adjust the I to reflect the proper time units that we're working with. So I is going to be a periodic rate. It's going to tell us what is the interest rate per period of time, and N is going to represent the total number of periods that we're investing. And so periods are going to be time units like months, days, years, those kinds of things. So if we have monthly compounding with an account, that means we need our N in terms of months. If we have monthly compounding, we need our interest rate in terms of an interest rate per month. Similarly, if we have daily compounding, we need our N in terms of number of days, where I is in terms of percentage per day. All right, so let's do a problem. So let's say Sam deposits $100,000 today into an account that pays interest of 10% per year, but this account is going to be compounded semi-annually. We get interest twice a year. How much is he going to have in the account at the end of 2 years? All right, so I'll set up my chart. So we're going to have N, I, PV, FV, and PMT. All right, so N, what is our N going to be? So we're going to invest for 2 years, but our compounding frequency is twice a year. We're doing it semi-annually. So I need to multiply this by 2 periods per year, which is going to give me 4 semi-annual periods. And we have to do a similar adjustment to I. So our interest rate is 10% per year, but we need to break that 10% up into two pieces. So 10% we get semi-annual, we get paid semi-annually. So this is going to be 5% per semi-annual period. All right, so notice we have the 2 here. We divide by 2 to convert the interest rate to semi-annual, and we multiply by 2 up here to convert the N into semi-annual periods. So 4 semi-annual periods we're investing, and we get 5% interest per semi-annual period. All right, the rest is just standard. Our PV is going to be negative 1,000, and we're solving for FV, and we'll leave payment as 0. All right, let's go to the TI-83 calculator to try to solve this. All right, we have our calculator up, and solving this is going to be similar to what we have already done. Nothing really changed at all. So I'll go into apps, I'll go into finance, go into my TVM solver. So my N is going to be 4 semi-annual periods. So I can actually just do the math inside the calculator. So I'll have 2 times 2 gives me 4 semi-annual periods. My interest rate is 10% per year, but we're doing it twice a year, so I need to divide it by 2. So I get 5% per semi-annual period. My PV will be negative 1,000, PMT will leave it as 0, and I want to solve for FV. So alpha enter on FV, and I get 1215. All right, so that's my future value in this account if we have semi-annual compounding. Let's see what happens if we increase the compounding frequency. What if we get interest not twice a year, but let's say we get interest every single month? So what we would have to change in there, we'd have to change our N. So our N, if we get interest every single month, so we're investing for 2 years, but we get interest 12 times a year. So I'll do 2 years times 12. There's going to be a total of 24 periods over this 2-year long time span. And my interest rate, I have to adjust that as well. I need to turn that interest rate into a monthly rate. So my interest rate is going to be 10% per year, but I'm breaking it up into 12 pieces. So the result is 0.83% per month. And everything else remains the same. My PV is still at negative 1,000, and I'll go to future value to compute a new value. So I'll do alpha enter and get 1220 as the future value if I have monthly compounding. And so as you see, as the compounding frequency increased, the future value increased as well. So we can keep extending this. We can get interest every single day, every single minute, every single second. So we can keep getting to smaller and smaller increments until we reach a limit. And that limit is called continuous compounding. And so I want to find out what's going to be in this account if we have continuous compounding. So the way we're going to do that is we have to use the exponential function. So the formula for future value is going to be, so the future value with continuous compounding is equal to the present value times E raised to the APR times the number of years. All right, so let's plug in our numbers. So our present value is equal to $1,000. So we don't have to deal with the negative sign here because this is a formula. We just need negatives when we're dealing with technology, either Excel or the computer. So we have 1,000 our present value times E raised to the APR, which is 10%, so 0.1, times the number of years we're investing, which is 2. And the result of this turns out to be 1221. 40. All right, so a little bit bigger than what we had with monthly. And so as you see, as the compounding frequency increases, the future value increases as well. Let's do another problem where in this case we're solving for N. So we want to find out what is the N when we have multiple compounding periods per year. For this one, it's really important that you pay attention to the units. So let's do this. So you deposit $1,000 into an account that pays 6% interest per year, compounded daily. So you get interest one time a day. How long will it take for your account to double in size to $2,000? All right, so I'll set up my chart. So we have N, I, PV, FV, and PMT. All right, so we're going to solve for N. We want to know what our N is going to be. Our I is going to be 6% per year, but we get interest every single day. So we need to divide it by the number of days in a year. So 365. And this gives us 0.016% per day. Our PV is going to be negative 1,000 because we're depositing that. And our future value is 2,000. We want to know it's going to double in the future. So we're going to have $2,000 in the future. PMT is 0. And now let's go to Excel to find this value for N. So let's do this in Excel. So the Excel command to find number of periods, N is equal NPER. So my rate is 0.16% per day. So I'll type that in here. And so I need it in Excel to be in terms of decimals. So this is going to be 0.00016. That's my 0.16% per day. Comma, our payment is going to be 0. Our PV is negative 1,000. And we'll make our FV 2,000. For type, we'll leave it as the default, which is 0. Close parentheses. And what do we get? We get 4,332. All right, so what does that mean? 4,332 what? That's going to be days. So the units on these are days. So when you solve for N, the units that come out are going to be consistent with the units on the interest rate. So if we have a daily interest rate, the result that we get here is going to be in terms of days. So the answer to this one is 4,332 days. We'll do one final question, which is finding the effective annual rate on investments. So in a lecture, we did this example, but let's do it again, showing how to solve this, not using a formula, but by using a calculator. So suppose you're looking at two savings accounts. One of them pays 5.25% interest with daily compounding. The other one pays 5.3% with semi-annual compounding. And we want to know which of these accounts we should choose. So we should know that we can't directly compare these two rates because one of them has daily compounding and the other one has semi-annual compounding. So what we're effectively earning in these two accounts isn't comparable. The only way we can make them comparable is to compute an effective annual rate. So let's do that. Let's compute effective annual rates and make these two things comparable. So I'll do this first one account using the calculator. All right, so the first account pays 5.25% with daily compounding. And I want to find out what's the effective annual rate with that account. So I'm going to go into apps. I'll go into finance, and then I'll scroll down towards the bottom to where I see this C, which is EFF. So I want that. So I'm going to press enter to get into that menu. And so now it's asking me for a couple of inputs. My inputs are going to be first, what is the APR in terms of percentages? So this is going to be 5.25%. My next input is going to be the number of periods per year. So I'll press comma, and then the number of periods per year on this one is 365 because we have daily compounding. We get 365 interest payments within a year. So I'll do 365 as my number of periods per year, close parentheses, press enter, and I get 5.39%. That's going to be my effective annual rate for my first account. So I'll go ahead and write that down here. Account number 1, we have 5.39% is our EAR. Now let's do account number 2 using Excel. For account 2, we have 5.3% interest with semi-annual compounding. So in Excel, what I would do is I would type in equals to bring up my functions, and then I'll type in effect. And that's going to return the effective annual interest rate. All right. And so what I'll type in is the interest rate that I had, which was 5.3%. So I need to put it in as a decimal. So 0.053. And then I need the number of periods per year. So we have semi-annual compounding, so we get 2 interest payments per year. So my number of periods per year is equal to 2. So I'll close parentheses there, and then I get 5.37%. All right, so the second account gives me 5.37%. All right, so now we can compare these two since now they're in the same type of units, and this tells me that I should go with number 1 because it gives me a higher effective annual rate. All right, so those are all the problems I have. Thanks for sticking with me, and hopefully these helped out a little bit.